This is the intro video for Algebra 1. Section 6.1, we're going to be looking at the greatest common factor and how to factor out the greatest common factor in this video. So the steps are to factor each term. Once you factored each term, we're going to identify the common prime factors, and the greatest common factor will be the product of all the common prime factors. So we're going to start off actually doing a really old question, something you probably did back in middle school. We're going to use some factor trees to factor out each of these numbers. So 36 is 4 times 9, 4 is 2 times 2, and 9 is 3 times 3. So we're going to remember that the prime factors of 36 are 2 times 2 times 3 times 3. And then we're going to do the same thing with 54. So 54 is 6 times 9, and 6 is 2 times 3, and of course 9 is 3 times 3. So again, we're going to remember that those four numbers are the prime factors of 54. And then lastly, the 90. We're going to remember that 90 is really 9 times 10, 9 is 3 times 3, and 10 is 2 times 5. So we'll remember that those are the prime factors of 90. I'm going to come over here to the side, and I'm going to list out the prime factors horizontally, and I'm going to go in order here. So for 36, it's 2 times 2 times 3 times 3. For 54, it's 2 times 3 times 3 times 3. And for 90, it is 2 times 3 times 3 times 5. Okay, so I'm just going to try to line these up here. I can see that there is a common factor of 2. 2 is in each of these, is a common factor in each of these numbers. And I can also see that there is a 3 in common. But then if I look at these two columns here and here, I can see that, let's see here. I can see actually there's one more line of common factors, and that would be there are 3's as well. So each one of those has another 3 that's in common. So at this point, that would be it as far as common factors. The greatest common factor is going to be the product of those three numbers. So 2 times 3 times 3. So our greatest common factor is 18. So what that means is that 18 is the biggest number that will go evenly into all three of those numbers, the 36, the 54, and the 90. Okay, so we're going to move on to our other example next. The example we just looked at was an example where we were finding the greatest common factor of three different numbers. And so what we're going to do now is we're going to take that same idea and we are going to try to factor out a GCF, or factor out a greatest common factor out of a polynomial. An important thought here is simply that factoring is taking an expression that's a sum or a difference and transferring it into a product. Another way to think about it would be factoring is taking an expression that is not a multiplication problem and making it into a multiplication problem. We're going to find out during this chapter that that's a very useful skill, something that we'll use to help us solve equations, and we'll see those coming up a little bit later. So our one example here says factor out the GCF, the greatest common factor, and the expression we have here is 9a plus 27. So you can see that I've got two terms. There's one right there and there's one right there. So two different terms, and we want to figure out what is a common multiple in both of those terms. So for example, the a here, that is a factor within the first term, but you can see the second term does not have an a. So we would say that a is not a common factor. So we're not going to be able to factor out an a. I look now at the numbers, the 9 and the 27 right there, and I want to ask myself, is there a common multiple between 9 and 27? In other words, is there a number that goes into both? You might have thought of 3, and 3 certainly does go into both 9 and 27, but we're looking for the greatest common factor. So we want to ask ourselves, is there a bigger number that goes into both? Hoping that you're thinking of the number 9. 9 goes into both 9 and 27. So what we can do here is essentially reverse the distributive property. That's what this is, more or less. And we're going to undistribute or factor out a 9. So I'm going to factor that 9 out. I'm going to write it right there. And let's remember that with the distributive property, there's always parentheses involved. So I'm going to put 9 and then some empty parentheses here. We want to ask ourselves, if we did factor that 9 out, which we are doing, we want to ask what's left over. So my first term was 9a, and if I factor the 9 out, what's left over? Well, the only thing that's left over is the a, plus, I'm just transferring this plus sign on down. The other term was a 27, and if I factor out a 9 from a 27, 27 divided by 9 is 3. So it would be 9 parentheses a plus 3. So like I said, we're essentially just reversing the distributive property. If you wanted to check to see if this was right, you could just do the distributive property. I think you'd see that you'd end up with what we started with. Okay, I hope that worked for you. When you come to class, we'll do some more practicing with this. I'll see you then.